Okay, so this time you notice there's no box in this picture, so we can't use the whole 90 degrees thing. But whether I want you to focus that we do have two adjacent angles here, angles DBC and DBA. There are two rays that make a line. All right, so as a general rule of thumb, if you have a line in your sight, that means you have 180 degrees in this picture. So that would mean we would have to add our adjacent angles together and make it equal 180 degrees. So if you ever see a line, you should be using 180. And then we go ahead and solve for x to get 140. And then we make it just a little bit more work intensive, not a lot. So you can still see you have this line in the picture. That means your adjacent angles will add to equal 180 degrees. So we'll go ahead and combine these like terms. We'll add our 54 over, and then we'll divide by 18, and we'll get that x equals 13. So again, if you see a line, that means that you have 180. If you see a box, that means you have 90. These problems are going to look a little trickier because they didn't label the picture for you. They didn't put this math in the picture. So we're going to do that ourselves. So the first thing we need to do is read to ourselves that the measure of angle DBC. So find angle DBC. We could also call that angle 1. They're telling you that inside of that angle, you need to write 4x minus 6. So the way I show that is I draw a giant arc and I just write 4x minus 6. Just kind of gives me an idea of, okay, this is how far we lifted this thing up. Then we find angle ABD, ABD, and in between that angle, we want to write 6x plus 2. So we have ourselves two adjacent angles. You can see that there's a line formed using those two angles. So that means we have to add them and set it equal to 180. We're going to go ahead and combine our like terms, add our 4, and we will get a decimal, and that's okay. X is going to be 18.4. And just to specify, these arcs, these are just to help me kind of visualize that whole revolution. They don't mean that these are congruent. That's not the same thing as putting an arc right here in the corner. So we just don't want to confuse that. Now we're going to make it even busier for you, and this is the last one. So we're going to find angle DOC. DOC, so that's this angle here, and we're going to put 3x plus 20 inside of it. Then we're going to find angle COB, and put 10x minus 60 inside of that angle. Then it says that angles BOA, so here's angle BOA, and angle DOC are the same. It says that their measures are equal. So I'm going to copy what's in angle DOC into angle BOA. They told me they're the same, so therefore I can use the same expression in both. The last thing they tell you is angle DOA. That's this whole thing, D to O to A. That whole thing is 100 plus 4x degrees. So what you have is 3 adjacent angles that when you combine all of them together, you get this giant angle DOA. So we're going to add all 3 angles, 1, 2, 3, and that's going to equal the entire angle angle DOA. So we'll go ahead and combine our like terms, 3, 10, and 3 to make 16, 20, negative 60, and 20 to make negative 20. I'm going to minus the 4x over here and add the 20 over here and then divide by 12, and I find out that x is equal to 10. Now that I know x equals 10, I can go ahead and answer these follow-up questions. So the first thing it wants is angle BOA. Angle BOA has the expression 3x plus 20. I can now plug 10 in for x and then simplify. So that angle is 50 degrees. So this angle here is 50 degrees. Angle COD would also be 50 degrees because it says that they're the same. Angle BOC has the expression 10x minus 60. That's now going to be 40 degrees. Now there's two ways to get angle DOA. I can certainly use the expression 100 plus 4x and get 140, or I can just add the three adjacent angles. Now that I know what they are, I can add them together, 50, 50, and 40, and that also gets me 140. So totally up to you how you want to make that happen. So we'll be doing more practice with that, but that kind of gives you an introduction to the world of angles.